And his is on the left, right?
Yes.
Okay. So I think you just need to bring that. Okay.
We've already done this for years. I swear to you, every time we do it, it's different. It's different. Something's changed. It's so frustrating.
You good?
Board meeting tomorrow.
Well, it should be recording.
We're going to record it now. This is.
That's what he wants, right?
Oh, yeah. That's the one we got up. Like 10 degrees below. There's lower draw.
Okay.
Yeah, I still the time. It's like, oh, here.
Well, all right. Well, good afternoon, everybody. Now you know that how long it takes for Emeriti to turn on the Zoom. 5 minutes. Every time we come here, it's a different thing. And Dean and Scott do an excellent job of getting it up and running. I don't know how they do it. They just keep hitting the thing and it comes up. Yep, it takes practice. Good afternoon. My name is Jim Van Boris. I'm the president of the Emeritus Center. And Scott will introduce our speaker in a moment, but I do have a one thing. If I've said this a number of times, so if I'm being a bit redundant, I apologize, but we have new people and other people listening, and I want to be sure this word gets out. The Alley Lifelong Learning Institute work that we've been doing will become live in January. The classes are going to start in March. I'm going to go run down the classes. We've got 3 of them lined up. On Tuesdays, the Controversial Insanity Defense in American History. That's by Richard Hom. On Wednesdays, Aging Well, Living Well into Your 80s and Beyond. Yuchi Young will teach that. And on Thursdays, non-Victorian fiction, 1966 to 2023. Randall Craig will be providing that instruction. So those are all lined up. In January, you'll be able to go online and sign up, register. Hopefully you're able to find time to come to one, or you can come to all 3 if you'd like. We're looking forward to it. Carol and others have done an outstanding job of putting this together, and I really think this is going to be a big success. So hopefully we'll see you there. This is our last speaker for this semester. Scott was talking earlier. I can't let it out of the bag yet, but he's got some really interesting people lined up for next semester too.
President Rodriguez next week.
Oh, President Rodriguez will be on the 9th, December 9th. He is going to come over and present to us of what the university's up to. And after that, I'll do a short presentation of what the Emeritus Center has been up to and where we stand. So thank you, Ed. So I'll turn it over to Scott.
Thanks, Jim.
Get on the way.
And this is our last meeting this semester, but our first interesting speaker for next semester starts with Nick today. And I found my glasses. Thank you. Dr. Nick Basill is an atmospheric scientist with a background in numerical weather prediction, forecasting, data science analysis, data visualization, and a desire to apply those skills to emergency management and other public sector uses of weather data and analysis. His current position requires significant public outreach to organizations such as state agencies, utilities, educational entities, and others, engaging them on how weather affects their operations. Guess who was busy this week? And stakeholders. Every week. Nick's early scientific career at the University of Wisconsin-Madison, where he received his PhD, and the University of Utah, where he focused on modeling hurricanes, was reflected in his extensive work on the predictability of Hurricane Sandy's 2012 tract. In 2014, Nick joined the New York State Mesonet before they began the process of deploying a $30 million weather observing network. Due to increasing demand for operational weather services by New York public entities, he saw the need and advocated for the creation of a publicly funded state weather risk Communication Center. He was successful, and it was created in 2023, and he currently serves as its director. Nick's been very busy with our extreme weather. He's been cited in the media no fewer than 4 times during the recent week of November 18th through 22nd, as per our UAlbany News. With livescience.com, he did a piece on why isn't the darkest time of the year also our coldest. On Spectrum News 1, he did examining the role of weather data during extreme weather. In Yahoo Life News website, he did how to stay safe and warm in the winter weather, expert tips on your home, your car, and your family. And finally, WNYT, Capital Region air quality is affecting us during the wildfires. Luckily for y'all and me, I'm going to step aside. Won't you welcome Nick Basill?
Thank you, everyone. Thanks for having me. Thanks for some former colleagues of mine for joining us. So yeah, I'm going to talk about mostly the latter half of that introduction, just sort of what I've been up to here at UAlbany, and discuss the broader, what we might call weather enterprise here at UAlbany, and how that interacts with the state and how that's changed. So it's sort of jumping a little bit to the end here, but here's a picture from when we filmed our announcement for the State Weather Risk Communications Center, which I'll get into a little bit later, but that's me before I had a beard, and Al Roker and Governor Hochul, if you can't see it. It was announced on the Today Show on December 7th, so last year. So we're almost to our 1-year anniversary, so to speak. So since I know this building is new for almost all of you relative to when you may no longer have been affiliated with UAlbany, but we have this brand new E-Tech building, really nice building on the Harriman campus. And I've annotated it here with some of the sorts of weather or weather adjacent organizations. So we have twin basically weather departments here. There's ASRC, which we have some faculty here visiting us now, and DAS, the Department of Atmospheric and Environmental Sciences. They're sort of like the teaching department, whereas Atmospheric Sciences Research Center is a little bit more of an applied or researchy kind of organization. That's what I'm a part of. There's the New York State Mesonet Center of Excellence, Excite Lab, that's a machine learning laboratory. And then my center is in the back. There's the local National Weather Service office. I think most people maybe don't know that, but the Weather Service, the Federal Weather Service that services our area, their office is here on campus. And then relatedly, the College of Emergency Preparedness, Homeland Security, and Cybersecurity, which is relatively new, is also in this building. So all of these groups work in the weather area in some way or another. So I'm going to talk a little bit about a couple of these more specialized organizations, the ones that I have been a part of since my time here. So I mentioned the 2 departments. I'm not going to get too much into them, but we can answer questions about that later if you're curious. But the one that's kind of starts off everything here, the New York State Mesonet. So I came here about a decade ago, just over a decade ago, when that was being funded. And an important part to note here is that since its deployment, this has about a $1.5 million per year price tag. So it costs money to operate. And I'll explain why that's important as we go along. The Center of Excellence was funded very shortly thereafter, and the state of New York, the state of New York funds about a dozen of these so-called centers around the state. And the idea is that they take what that institution is good at and apply it to the private sector of New York in hopes of enhancing their job creation or save money or whatever. So we have a lot of weather stuff. Ours is weather-based, work mostly with utilities and renewable energy and that sort of thing. And they get $800,000 per year of funding. The State Weather Risk Communications Center that we'll be going into more, you can kind of think of it as the same exact thing as the Center of Excellence, but instead of the private sector, it's for the public sector. And so that gets about $1.5 million from the state. Okay, so why do any of these things really need to exist? And the answer is pretty simple. Most weather-dependent organizations don't have meteorologists. it was kind of surprising to me to learn, as I was a relative newcomer and learning this, but they don't. So there's a sort of weather gap where a lot of these organizations, and it could be utilities, it could be renewable energy, it could even be a hospital, it could be a school, like you name it, they have weather events that affect them. They need to plan for them or respond to them. And if you don't have a meteorologist, it can be tricky. And so obviously, the Hurricane Sandys, the Buffalo blizzards, those are pretty obvious big weather events, but even these little nuisance ones. And the trick is you could even have no weather event and it can still cost the state millions of dollars. And the reason for that is, say you're a utility and you're worried that you're going to have really huge thunderstorms tomorrow afternoon. Maybe you call in outside crews for millions of dollars and the thunderstorms don't happen. Now you spent millions of dollars to prepare for no weather. So that kind of stuff happens all the time. And if you're not a meteorologist, this is not an exhaustive list, but this is just a few things that, I've run into or we've done in the past year or so. Could you find snowfall observations in the middle of a map? Do you know what a return period is for an extreme rainfall event? If we had a flood yesterday, was that a 1 in 100 year event, 1 in 1,000 year event? That kind of stuff is important for insurance purposes, other types of disaster recovery tasks. Could you do a training event for your coworkers? If you don't know how to forecast the weather, how to look up the weather, could you create a realistic training exercise? Probably not. If there was a wildfire going on, could you do a spot forecast for the DEC firefighters out there? There's a whole humongous range of things that are super important that obviously I won't talk about all of them, but you need a meteorologist sort of in the loop. So the story starts with the New York State Mesonet, and that was what I came here to work for in 2014. And they are a network of really high quality weather stations that we'll get into in a second. The first one was deployed in 2015, and then most were deployed shortly thereafter. So this is a nice picture of one of them. This is just a really high level summary of everything, but really what's important is that the idea was conceived of after Hurricane Irene in 2011 and funded after 2012 in the Sandy Supplemental Relief Bill. And that gave New York $30 million to install this really nice, high quality network of weather stations. And those stations were finished up in terms of installation in 2018. So since 2018, they have all been live, and they have since expanded to a variety of other sub-networks for more specialized applications for research and elsewhere. But you can think of them as a really, 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 really nice, backyard home weather sensor, but can't really put enough reallys on there because, as I said, it's a $30 million network of super high quality stations. And so the reason for this is, well, actually, I think I have it. Yeah, right here. So on this slide, all of the blue dots, and it doesn't really matter if you can't really see exactly where they are or read the text on their locations, but all of the blue dots are where they are. So they're pretty much spread evenly across the state. And the black dots are what we had before. And so basically, if you can't see that, there were a lot of stations in New York City. That's great. JFK, LaGuardia, Newark, they all had weather stations. There's an Albany station. There was a Poughkeepsie station, Syracuse. But if you lived in the Catskills or Adirondacks or much of the Southern Tier, Tug Hill, you had very, very, very few weather stations to tell you what was happening, which was a big problem. So this is a view that one of the technicians who works at the New York State Mesonet took with drone footage from a particularly snowy and pretty site a couple of years ago in the Tug Hill Plateau. So just gives you a sense of what it might look like if you just went to go visit it today. And if you went to go visit it today, it would probably look very similar because they had quite a bit of snow over the last couple of days. So what is there? When you think about weather, you can probably guess what kind of instruments are there for the most part. Something that collects the rainfall, wind speed, temperature, humidity, that sort of stuff, pressure. But there's a lot of stuff that you may not immediately think of when you think about the weather, like soil temperature and moisture. That's really important. There's redundant temperature sensors, so that is a huge help. There's radiation, so how much sunshine basically is reaching the ground. There's a snow depth sensor. There's something that you may not think of as an instrument, but functions that way, which is a camera. Every site has a camera, and that ends up being actually really valuable when you're trying to diagnose various weather phenomena. So that's useful. So every site has the same setup. There are 127 around the state, if I didn't say that. So just kind of Mesonet in action here. On the left is an animation of radar during an extremely large snowstorm that we had almost exactly 4 years ago today. Not quite, but right before Christmas, we had a really significant snowstorm in 2020. On the right is at the same exact time, the measurements of snow depth from the Mesonet. So you'll see as that those greens and really heavy stuff on radar, really heavy snow bands move through New York. You see an explosion of colors here, and that's just saying that the Mesonet is observing in real time, 20, 30 inches of snow. So why that's important in real time is normally, if you were trying to say how much snow fell, say you were in Albany and you're trying to figure out how much snow fell on the Tug Plateau over this weekend's lake effect snow, you would have to wait for someone to manually go out, put a ruler in the snow, hope first of all that they did it, because they might not, maybe that they can't or don't want to, but have to wait to go till they do that, report back. They generally report once every 24 hours is typical. If you're lucky, it's every, say, 6 to 10 hours, 12 hours. But you just have to be at the mercy of what people are going to tell you about how much snow fell. So it's nice to have that sort of automatic thing. So the problem with the Mesonet, and it's not a problem with the Mesonet in particular, but a problem with its sort of usefulness, is that because these sectors who are dependent on meteorology don't have meteorologists in-house, if you have this amazing data set for them and you say, here, it's for you, please make use of this, they will say, I don't know, what do I do with that? What do I do with a CSV file of a whole bunch of numbers? How do I know that this is any different from my, my phone app that tells me the weather, or my backyard temperature sensor, or anything like that? It's a struggle, right? And so we need sort of like a go-between, a middleman in a sense to help connect those dots. And from the Mesonet's perspective, as the funding was used to install the stations, then came the maintenance afterward. If you have all of this equipment, it takes time and effort and money to maintain, so you need additional funding. So if you're going to, say, the state or someone else and say, can we have some money to maintain these? If you're not a meteorologist, it might be logical to say, well, isn't it already there? Why do you need more money? Like, it's already installed, right? Doesn't it just operate? So, you really have to connect the weather dots here to what do we have in existence? What problems do you have? And how do we put those two things together? The problem is a lot of people who might use this data are emergency managers. If you're an emergency manager, as the name might imply, they focus on emergencies. And if you have an emergency when you need the weather, you're not likely to set everything aside and spend an hour figuring out how to use what you have available if it's an emergency. So you really need to somehow convert it into as easily digestible of a product or tool or briefing or whatever it is as you can. So one of the questions that we got at the Mesonet early on is, with all that equipment, you must make great forecasts. Maybe not a question as much as a statement, but that is intuitive, right? If I told you there was an amazing amount of really expensive weather equipment in New York, you would say, wow, that must really help with the forecasts. And it may indirectly, but really it's telling you what's happening right now. If you take your temperature with a thermometer, that doesn't tell you how warm your fever is going to be in 2 days, right? It tells you what it is right now. And that's kind of what's happening with the Mesonet here. So we get questions like that all the time. And this kind of relates to that center of excellence that I mentioned, where we have a separate organization here at UAlbany that gets funding from the state to help the private sector in New York with their weather problems. And that center can do a lot when it comes to forecasting. So I'm not going to get into every one of these projects here, but I just put a summary of all of the ones that at least I've worked on that is not, or people I know have worked on. This is not exhaustive. I'm sure I've missed a couple. This is just what I knew off the top of my head, but just with utilities here in New York. And so there's probably been about a 10 or so, probably more, because I'm not thinking of all of them, but in the last 7 or 8 years or so, where we've worked with utilities to help them forecast weather in some capacity. Hopefully using the Mesonet if we can, but not necessarily. Sometimes we do other stuff. So here's an example of an outage prediction forecasting project we were doing with Central Hudson Gas and Electric, which is a little bit to our south. I'm not going to super explain this plot, but the idea is it is a how long since the wind has gusted from a particular speed and direction. And the reason why that might be important is if I told you that we were going to have a 60-mile-per-hour wind gust later today, and I told you it was from the west, and then I said, or we could have a 60-mile-per-hour wind gust from the east, it may not be intuitive, but those two things would likely have drastically different outcomes in terms of their damage potential here in New York. And so the reason is we fairly frequently get 60-mile-per-hour winds from the west. Our winds are generally from the west here in Albany. Thunderstorms generally move west to east. We often get those kinds of wind gusts. And so the trees infrastructure is a little more hardened to that, but we never get 60-mile-per-hour wind gusts from the east. And so if you got one from the east, suddenly you would have a lot of loose tree limbs that aren't normally exposed fall down, billboards blow over or whatever. And so if you're planning on how much damage might occur, kind of knowing that information is useful. So that's just like an example of the kinds of things you can do with forecast data or Mesonet data or whatever to help people be a little bit better prepared for what impacts might happen. Okay, so the rest of this is sort of on our long trip to how the State Weather Risk Communication Center was created. And this starts with a snowstorm on November 15th of 2018. And I know this was about 6 years ago. You may recall this one, not because of what happened here, but because of what happened in New York City. Basically, it was a Thursday night, and the snow hit very hard right at rush hour. It's first snow of the year. They got 4 inches of snow in an hour and a half or so, right at rush hour. The city screeched to a halt. People were stuck on the roads all night, and it was a big story. Just worst possible timing for something like that. Up here in Albany, we did get some snow overnight, but it didn't. It kind of switched to rain. It was sort of a gross mix of stuff, like it seems like we always get here in Albany lately. But they closed schools. They saw that on the news. Closed schools the next day, on Friday. And by 9 a.m., the sun was out. We only had an inch or two of snow on the ground. Parents were angry, right? It's an economic thing. Parents have to take off work. They have to hire a babysitter. They have to do something like that. The kids aren't learning. Again, an example of you can spend millions of dollars getting no weather. A good example of that. So the local school, BOCES, the Boards of Cooperative Educational Services here in Albany, came to us and said, can you help us with this for the next time so we don't, make this kind of bad decision again? At the time, it was mostly just me. So we're like, well, I'm not gonna be on call for every school in the state. It's not very feasible. Can we make something that is automatically made that helps them sort of be their own meteorologists in a sense? So we made something like this, and I'll kind of go through it one step by step. It's just a really simple table that updates regularly. And on the left, you might have different types of weather variables. So in this case, snowfall. So, are you getting 1/10 of an inch, 3 inches, something like that. They're very arbitrary, but they could be whatever values you care about. Then on the top, you just have a time frame, 5 to 6 a.m., 8 to 9 a.m., whatever. So if you were, say, a school superintendent, you said, well, my drivers get in to get the school buses. They come in around 6, and then at 7, by 7, they're out getting the kids, and then they come back at 8 a.m. And so if the roads aren't going to be passable during that time, then I'll know to cancel or delay school or something like that. And then finally, the other part is just how likely a given scenario might happen. Are we going to get an inch of snow between 7 and 8 a.m.? Is there going to be no snow at all? Is there no risk of any snow between, 6 and 7 a.m.? And that's what the kind of color codes here mean. So you put it together and you're at something like this. And we made this not at the time, but retroactively for that event with the weather data that we have available to us. And basically, if you were a school superintendent making decisions for the next morning at say 9 p.m. the night before, you may have said, hey, after 9 to 10 a.m., we have no chance of any snow. And in fact, once you get to, say midnight or so, our risk of having an inch of snow goes down dramatically. So I probably don't have to be too worried about that scary news story in New York City, and we can go ahead and have school. So sure enough, so snow would stop by 10 a.m. There's a radar at 9 a.m. Albany's like right here, and then by 10 a.m. no snow. So that's kind of what started us on this journey. And again, we were still just 1 and then 2 and then 3 people, but still not enough to really be there for sort of everyone. And so we kind of started expanding this, what we call dashboard. Everything's a dashboard now, dashboard of weather data, dashboard of business data, dashboard of sports data, whatever, but started expanding this concept to other groups in the state who cared, like the DOT and the MTA and DISHES, which is the state's emergency management, utilities, the Port Authority, just added more bells and whistles and different time frames. And it's not really worth getting into, but it just sort of kind of organically kept growing. The problem was all of these, they needed a home, and their home was a center of excellence. And if you recall, I said that was here for the state's private sector. And almost all of those groups are the state's public sector, the DOT, MTA, DISHES, so on. So let's consider, switch gears a little bit. So in 2021, I believe, Governor Cuomo resigned, and then Governor Hochul took office. And about a week after she took office, Hurricane Ida's remnants happened and hit New York City. And they produced a dozen or so deaths, flash floods, just extensive damage. She said, what did we know? When did we know what we had? What information did we have? Were there any intelligence failures in terms of our preparedness? Could that have been anticipated? I want to find out. So we sort of took that as a little bit of a challenge. And to understand why that's important and what we're going to do here, so I want to talk about how much rainfall happened in New York City. So if you were out there scanning the news, you would have said in Reuters, hourly rainfall record of 3.15 inches in Manhattan, ABC, 3.15 inches of rain in just 1 hour, New York Times, over a single hour, Central Park recorded 3.15 inches of rain. So if your question is how much rain fell in an hour, you would have said 3.15 inches, right? But in actuality, they're talking about this station right here, this purple dot. That's one of the traditional weather stations that the National Weather Service maintains. But this map is a map of what the peak hourly rainfall was for New York City. And if you can't read it, here's a 4.1, 3.8, 3.7, 3.6, 3.7, 3.9. You get the idea. It was closer to 4 inches, not 3.15. So why is that discrepancy important? Oh, yeah. Sorry, I have a little, for those Star Trek lovers like myself in here, I got a little meme here with Jordy saying, no, it's not 3.15. It's actually 4.14. But why is that distinction important? And how did we get that discrepancy? Well, our traditional weather stations, the ones that existed here before the New York State Mesonet was installed, they traditionally report once per hour on the hour. Technically, it's a couple minutes before the hour, but that's not important. So if you have, say, a rainfall running total that looks something like that, where your blue lines there are your reporting times. If the true peak rainfall happened between these two blue lines, you wouldn't be reporting that. You'd be reporting what happened here and what happened there. But the New York State Mesonet is giving you basically continuous observations every 5 minutes. So you can pick out your true peak of rainfall, and that's basically what happened. Our traditional weather station is just missed when the true peak of rainfall is. So why is this important? Well, if you're an engineer and you're designing things like sewers or culverts or any other kind of infrastructure, you designed it around a certain amount of rainfall in a certain period, or more generally, a certain amount of water in a certain period. For New York City, that is 1.75 inches of rain per hour. Now, in this case, 3 inches or 4 inches kind of in some way doesn't matter because they're both well above 1.75 inches. But you can see why knowing that correct answer is very valuable to you if you're trying to understand when floods happen. Obviously, the infrastructure itself doesn't care at all whether or not the rain fell from 30 minutes to 30 minutes versus 0 minutes to 0 minutes on the hour. It doesn't care about that. So that's a very artificial thing. So how can we connect those dots? So getting back to what I said about emergency managers are not going to want to sit and figure something out when they're in the midst of an emergency. Can we put those two things together? Well, it turns out you can do that quite easily if you are knowing how much rain is falling in real time and you know what your sewer capacity is. That doesn't change really. You can just put those two things together and say, okay, how many did we exceed our sewer capacity? If we did, how many hours did we do it? It turns out for Ida, that was exceeded for about 2 hours or even a little bit more than 2 hours for basically all of New York City. The entirety of New York City exceeded their sewer capacity for 2 straight hours. Hence why there was so much damage and flooding during Ida. Okay, so fast forward to last September 2023. They didn't quite get an Ida level storm, but they had a very significant rainfall event. And this is that same map. How often did you meet or exceed your sewer capacity? And so if you can't read the screen, basically when you see blues, that's just, hey, you didn't meet it. Great, probably no flooding there. You see the greens, that's 1 to 2 hours. That's where they had flooding. So let's use that case as just like an example of why it's important to kind of look at this data a little bit more closely. So I'm just going to take a sip of this delicious DeBella soda. If you were not a meteorologist and you were looking at a map of total rainfall, this is what you would see for that day. What you would see is a lot of these orange or tan and white stations, or the purple ones, in most of central New York City here, got about 6 or 7 inches of rain. JFK, the airport, got almost 9 inches of rain. So intuitively, you would probably say, well, if any place got flooding here, it's probably JFK because they had the most rain. So intuitively, they probably got the most flooding. But they didn't. And the reason they didn't is because they didn't get the most rain in the shortest amount of time. So if I tell you that it rained 9 inches, that's really impressive. But if it was very evenly distributed throughout the day, then your sewers and runoff and whatever can handle that. So here's a map instead of the most rainfall in 1 hour throughout that entire event. You got 3 inches in Brooklyn, 2.5 inches elsewhere in Western Queens, and 2 inches or so up there in the Bronx and Manhattan. So if you recall, I said they can handle 1.75 inches of rain per hour. They can't do more than that. So that's why for that event, Brooklyn flooded a lot. And over here at JFK, their peak rainfall was only about 1.25 inches per hour. So they were okay. Less than 1.75 inches. Great. That's why they didn't flood. Okay. Here's just a kind of a demonstration of looking at 3 different stations here. This graph goes over the course of 24 hours, and it basically is just a running total of rainfall over 24 hours. So what I picked here were 3 stations that ended up with almost the exact same total amount of rainfall. They all ended up with almost exactly 7 inches of rain. But their peak 1 hour rainfall here, 2.78, here, 3.09, and here, only 1.05. So that's why Queens didn't flood and the other stations here did. So it's not necessarily about what your total was, it's about how you got there, right? And that I'm not going to show a snowfall example of this, but it works the same way with snowfall. If we got a foot of snow, but we only got 0.5 inch per hour, over the course of a day, that's something that the plows can keep up with. But if we get a foot of snow in 3 hours, where you're getting 4 inches of snow in an hour, the plows will not keep up with that, and you will not be able to drive during that time. Okay, so that's just some kind of explanation of, hey, why do we need meteorologists in this process? How can they help? And that helps motivate us for how we're trying to pitch the State Weather Risk Communication Center. So, as I mentioned, top 2 things here: Mesonet data. It's awesome, but it can be really tough to use if you're not, in the know about how to use that data. We also started this series of projects with public sector groups, education, Thruway, MTA, whatever. And those were based in a organization here on campus that was here to support private sector groups. So they couldn't really benefit from it in a reporting standpoint. Everything's about reporting nowadays. So if you're trying to demonstrate the value that that center of excellence is giving back to the state's private sector, and you're doing a lot of projects with the public sector, you can't really put that on your end of year report. It's just sort of a nice to have, not a helpful thing. These projects, they forecasted on making products, forecasting, uncertainty, and let's see. So they're said all that stuff. So our idea here was kind of twofold. I mentioned right off the bat that New York State Mesonet costs about $1.5 million to maintain. They make about half of that amount through various projects that help fund them. The remaining half is generally picked up by UAlbany. UAlbany supports their continued existence because they believe in the mission, and it generates good publicity, and it's a good thing to have, and it helps with research dollars and all of that kind of stuff. And yet, it's not a very comfortable spot to be, right? If you work for the Mesonet, knowing that UAlbany is picking up out of, in some ways, the goodness of their hearts. You'd like to have that be a little more sustainable. And so we'd like the state, if we can, to pick up that tab instead, because the state is benefiting the most from it. But they've been unsuccessful in sort of getting to that point. So part of that, I suspect, is that, it's much more sexy to cut a ribbon and open up a new facility than it is to just pay to maintain something that already exists, right? So that's part 1. Part 2 is that we had been doing all of these projects for state agencies and authorities. Almost all of them were based for 1 year. They all have various procurement rules for the state. You can only spend a certain amount of money if you're not doing a bidded contract. So they had to be relatively small dollar amounts for short periods of time. And if you're trying to hire, say, more staff or get any kind of continuity from year to year, it is very difficult to do that with those sorts of rules. So we said, hey, why don't we pitch to the state? Let's make this new center. Let us get all of the people that we need, computers, whatever tools that we need to start doing this in a more dedicated fashion rather than an ad hoc fashion. And let's also have enough money to support the Mesonet. That was the goal. That was sort of our pitch. And since, I know this is a UAlbany community, I thought you kind of might like the sausage making a little bit here. So we pitched it for 2 years. This is our first one. And basically said, hey, could we request $5 million? We're going to give $1.5 million of that to the Mesonet to help support them. $3 million for just hiring people, buying, a web server to put a website on, like that kind of stuff. And then $500,000 for New York vendors. And what I mean by that is we're not the only ones filling a gap that exists in the state for needing weather help. There are other small, like mom and pop weather companies in the state. I know that the New York City Sanitation relies on a local weather organization. We wouldn't want to put out of business any, great New York entities. So we said, let's have some money to make sure that those are funded. What we did not care about, and in fact was part of our push, was many times utilities or other state agencies or authorities, they will buy weather vendor services from sort of big box weather companies, AccuWeather, It's probably one you've heard of, but there are lots that you maybe have not heard of, like DTN or Tomorrow.io or Maxar. And when we do that, what we are doing as a state is we are taking hundreds of thousands of dollars. We are sending that out of state for someone in some other state who services the entire world to not use the New York State Mesonet data, because they don't care about New York State Mesonet data. They're here for the whole world. And that just doesn't make a lot of fiscal sense, right? We're spending money in a way to get poorer service in return. So that was part of our pitch too for helping create the State Weather Center. So we started getting letters of support and meeting with legislators and commissioners of different agencies and that sort of thing. And then while we weren't quite successful in year one, we started a pilot project of what the center would eventually become. And that was with our state's emergency management organization. And obviously they're, you know, if I say state's emergency management organization, you can think that they would be the greatest potential beneficiaries of this, and they would like to have the most say in this sort of project. And so we started this pilot project with them, where we did a little mini version of it, had a couple people creating real-time weather briefings for them, a few more easy to create products, helped with a few other tasks like create a Buffalo blizzard weather themed after action report, which we was the cover page right there. So just a couple tasks like that. And then by the second year, when we made our pitch, we were had a lot more letters of support. We had sort of demonstrated this value to our state's emergency management. Not great for New York, but potentially good for us making this pitch is that the Buffalo blizzard happened kind of in the midst of the second time. And it unfortunately sometimes takes a disaster for us to, kind of catalyze what we think we need. So talked to the Buffalo delegation there. But ultimately it was our state's emergency management Commissioner Jackie Bray. She comes with a little bit of a weather background, which is very helpful because she kind of knows what can and can't be done in this realm. Her and a number of others helped make this push and finally get us some success. So with everything, you ask for maybe what you'd like to have, or perhaps a little bit more than you'd like to have, but you're very grateful for anything that you end up receiving. So we got $1.5 million. This is recurring money from the state. So every year we get another $1.5 million. And this is because we are hiring full-time employees at UAlbany that we want to be here for the long run. We don't want, to have turnover after every year and all of that. So the money pretty much goes to full-time employees. Obviously in year one, there was some basic stuff like buying computers and that kind of stuff. But as we settle in, everything will just go to employees and interns. And this center takes over all the responsibilities for those prior small 1 year kind of projects I mentioned before with the DOT and Port Authority and so on. So we were announced on the Today Show. It was December 7th, 2023 when we were announced. We filmed it November 9th, 2023. So we're in sort of that gray period. We were kind of operating, but not technically announced yet. So we normally consider December 7th as our 1 year anniversary. So that'll be in about 5 days or so. Okay, so we are located in that E-Tech building that on slide 2 or so on the Harriman campus, just about a 10-minute walk up that way. And what we do are just basically trying to fill in any weather gap that may exist within the entire state's weather needs. And so a lot of the times that falls into the format of, can you create some sort of really detailed weather briefing for us? And as we mature a little bit, it will turn into making more products. So I showed that example of the rainfall and the sewer capacity, making more products like that as we get going. Just kind of general reporting needs. So for example, we had a lot of tornadoes, windstorms this summer. If the state is going to request disaster assistance, they need to demonstrate that certain weather things happened. Did we get that wind speed? Did we get that rainfall? Where did the tornadoes hit? And as you might imagine, if you're not a meteorologist, it may be tough to find some of that information, so we can help with that. Developing training exercises for people. We're at UAlbany, and UAlbany obviously is a teaching and service institution. So UAlbany now has a tool to create basically little mini classes for people who are not enrolled at UAlbany in the conventional undergraduate student sense, called micro-credentials. So we're creating basically weather map reading 101 that the state's public sector folks can take as a class. And I have here on the bottom, because it's a logical question, what about the National Weather Service? Aren't they here? Don't they do these things? And the answer is they're fantastic, and we love the National Weather Service, and they do some of these things, and some of them extremely well. And it would be very difficult for us to exist without them. And yet, they are a federally funded organization. They are not here just for New York, right? So our Albany office, it doesn't serve just New York. It serves Vermont and Massachusetts and Connecticut as well. So it's a little bit difficult to ask them to really participate in things that may be a little more political in nature, like say requesting disaster assistance. Clearly, they're not going to be doing teaching type things. They can't really make products in the conventional sense because the National Weather Service is somewhat of a one-size-fits-all for everyone across the entire state. So if we say, hey, we've got this cool New York State Mesonet, use this data in your products, they're not really going to be able to do that because that's not how their mission works. So just as a little kind of teensy brief or a look into our employees, I said we're hoping to have 10 once we get to full employment. We're at about 8 right now. So that's me, I'm the director. We have an admin, there are 5 meteorologists, and we just hired our social scientist, so basically someone who can help us with how do we best communicate things, or the language of what is used, or even things you may not think of, but if you're making a briefing, what colors are most appropriate? Where do you put the most important things on a page for people to see so they don't have to go look for them? Like that kind of stuff that is not my specialty, but is others' specialty. And the final 2 that we haven't hired here are the more kind of computery type people who are programming pros, can make web pages, that kind of stuff. And so that's why I say we haven't made much in the realm of products, but we'll get there as we have done. Since we have a great student population here, both undergrads and graduates, we have had a number of interns so far. So we've been averaging about 6 or so for the 3 semesters, spring, summer, and fall, and had 2 grad students, about 10 or so undergrads, and from 3 different departments in the 3 different colleges, I should say, at UAlbany. So a wide range of folks there. One of the things I just left this slide in because one of the things that I did not fully appreciate is how many just stuff that is completely unrelated to the mission of what you are trying to do when it comes to spinning up a brand new center. So, what I would love to do is spend all my time like looking at weather maps and, writing weather briefings and doing that kind of stuff. But as we're, spinning up, it's sort of calming down a little bit now, but just an absurd number, and this is not a complete list, but of just sort of required and important tasks to creating a space for people to work in, and just function like day to day. How do we communicate with each other? Does our center have an email address? Just like stuff like that. That's super important, but maybe kind of is taken for granted a little bit. So this is just, and not a complete list of just some of those types of things. Okay, so I'm gonna finish here by I've mentioned that we create weather briefings a lot. I was going to talk a little bit about what these briefings look like, or what different types of briefings we have. So we generally create what we call like a kitchen sink briefing every morning. This is 7 days a week, including Thanksgiving. We don't take off holidays. So weather doesn't take off holidays, so we can't take off holidays. A kitchen sink briefing every morning. Get sent out to a wide group of emergency managers and other kind of related people in the state every day. In there is page 1, a very fast summary. It's coming up soon. That page right there. Just it's sort of like if you're only going to look at one page, you're probably just going to look at the first page, right? So first page can let you know, should I look at anything else beyond the first page? And it contains, obviously, you know, are we going to get thunderstorms tomorrow or heavy rain or snow, that kind of stuff, but a whole bunch of other things that are adjacent to the weather that are also very important. Like, what is the air quality? What is the National Hurricane Center tropical outlook? Are there any hurricanes in the Atlantic that might threaten us in a week that you want to prepare for? What are the stages of rivers? Or is there active flooding from rivers going on? Climate outlooks. Has there been a new outlook that has been issued by the National Weather Service that says if it's going to be a warm winter or not? Can we put that in there? All sorts of stuff just sort of goes in there so everyone in the state can have a single thing to look at and not have to try to seek it out in different spots. So those are kind of the just, if we didn't do anything else, we would do that every day. But there's a wide range of sort of maybe more for fun type briefings. So I've put 2 examples here. The one on the left is what we call a spot forecast. So that's like, you know, an event is happening at a specific place and a specific time, and you just want to know what the weather is going to be like for that exact time and place. So we work with the state, and the state's parks manages the Saratoga Performing Arts Center, so the SPAC venue. So they asked us to give them a forecast for every single SPAC concert that was over the summer. This is an example of one from July 16th, when they had extremely strong winds and heavy rain. And so if you can't read that, we have the thunderstorm potential there, and we highlighted severe storms likely. For this event, they chose to ask people to not come in when they normally do, but to wait in their cars until the thunderstorms are over, because you don't want a lot of people outside amongst trees when it's really strong winds and lightning and heavy rain, obviously, right? The one on the right is for the eclipse that happened in April. So you might say, like, well, that's not really a weather event. Why are we doing that? And the reason is they wanted to know where people would be and what the weather would be like when people were leaving. So the eclipse had a very extremely defined, obviously, time when it was going to happen for every place. And so everyone, once it's over, is going to get on the roads and go on the roads at the exact same time. And if there were, say, like a big snowstorm or severe thunderstorms or something like that, that could turn into a big disaster really quickly. So they wanted to know what the weather would be like at the time that the eclipse is occurring and just before and just after. There are a lot more serious ones that we do. So this one, Buffalo Bills spot forecast, is actually not for last night's game. This was for the one in last January that ended up getting rescheduled. So if you don't follow football, they had a playoff game. Playoff game was going to be around 12:30 or something like that on a Sunday. It was rescheduled at 11 a.m. on Saturday and got moved to Monday. And so for those who don't follow football, that is a pretty much unheard of thing. You never, ever reschedule football games. And if you do, it's definitely not a playoff game. But this had been rescheduled before any snow had fallen in Buffalo. And it was absolutely the correct thing to do, especially because this was a game between the Bills and the Pittsburgh Steelers. And there was a situation where we have really heavy snow, really strong winds, and people would have gotten stranded absolutely for sure on the thruway going between Pittsburgh and Buffalo. And this is the kind of case where, you know, people were saying, like, well, okay, yeah, the weather is going to be really bad in Buffalo, but why don't you just move it to Detroit? The weather's going to be fine there. Not thinking, okay, well, if you do that, you're going to have 70,000 people from Buffalo get on the road and drive to Detroit. You're going to make the situation worse than if you just had it at the stadium in the first place. So lots of these kind of things, you know, people don't necessarily think of at the time. The one on the right here is for a migrant shelter on the far southern tip of New York City. So they have an old airstrip there that they have converted into temporary housing. with tents and other things like that. But because it's sort of exposed to the water, if you have a really strong south wind, you know, and like I said, it's temporary housing, so not permanent housing, it could be more susceptible to winds. So last December, around this kind of time, we kept having these really big rain and windstorms. And so every time we would create a forecast for them about what kind of wind speed it was going to be. And if it was going to reach a certain amount, they would evacuate them instead. These are different kind of outlooks. So basically, National Hurricane Center, we did a hurricane season outlook, just how many storms have we had? Is it likely to be really busy or quiet going forward? That's the one on the left there. The one on the right is more of a winter outlook. So this is a couple months after the one on the left. Just, you know, what kind of winter weather does it look like this season? What are the temperature trends? You know, what happened last year? That sort of stuff. What's normal? And then obviously wintry. So we're getting into sort of more winter type scenarios. So these are just two examples from around this, not quite this time last year, but last winter, talking about different scenarios where you might get, you know, where the snow might happen, where your rain snow line might be, and that kind of thing. And then finally, I mentioned we do training exercises. So this is our most recent one that we created. In this case, the DOT was planning for a fictitious lake effect snowstorm that didn't exist in reality, but they're doing a training event so that they could be prepared when they had an event like the one over the last couple of days. So they asked us to create a detailed fake briefing for weather that did not exist, but create maps as if they were looking at it in real time. And you'll see that we have, you know, start of the event, 96 hours before, 72 hours before, that kind of stuff. So basically, what would they have seen if they were looking at this in quote unquote real time as the event approached, and how could they respond to it? So when I say a training exercise, we can make stuff like this. And then if they want to use the National Weather Service as their partner in this, the National Weather Service can sort of play along in the game, so to speak, without having been spoiled by creating these themselves. So they're not predisposed to kind of know what's going to happen, and they can play as if it's a real event, and they can all work on getting better. Now the last couple I have here are just from this most recent weekend. So if you live in the Albany area, you know, we had rain and snow on Thanksgiving, obviously snow and rain in nearby areas. That followed a storm just a couple of days, about a week earlier, where there was a lot of wet snow in southern New York, caused a ton of power outages. We knew that we were going to get big lake effect snow off both Great Lakes after Thanksgiving, Friday, Saturday, Sunday. And so we had two requests, one from the DOT, which is one on the left, said, hey, can you give us a forecast region by region? And they have their own region. So they have 11 regions that are differentiated by county. Can you talk about, you know, how region 5 is going to have weather versus region 7 or so on? And then on the right, much of the state operates in these quote unquote REDC regions, Economic Development Council regions. And we were also asked to create forecasts specific to each one of those regions. So we were doing this day by day, starting last week, going through Sunday, and sharing those out. And then the person who's receiving this, they know what DOT region they are, they know what REDC region they are. They don't have to go hunt and try to figure out if what you're talking about for the whole state is relevant to them. They can just look only at that page. Oh yeah, I forgot I had one more here. Wildfire, you know, I am not, wildfire is mostly new to me in terms of how to think about it and forecast about it, and sort of relatedly drought. But, you know, we had a number of wildfires, not necessarily super close to Albany here, but more in downstate New York and the Hudson Valley. So we were asked to create a couple of briefings for those, and going to get into sort of like what happens publicly with this. But in this particular case, Governor Hochul retweeted a couple of these things. So I'm not saying that governor tweeting something is like an example of something being beneficial or anything like that per se, but clearly it is a sign that us putting this information out there is being at least considered valuable to some people. During that Buffalo blizzard, or pseudo blizzard, I should say, that rescheduled the Bills game, I got a call from our state's commissioner for emergency management at about 5 o'clock on that Saturday, and said, "I'm giving a briefing to the governor in 45 minutes. Can you put together 3 slides for me that tell me everything I need to know about the weather?" And so these are 2 of those slides. And obviously, you're not going to be able to create new content in that time frame, but luckily we have, those briefings I already mentioned. I could just basically steal from the timeline we already had with these other products that were automatically generated for the DOT. I could grab that. The Mesonet data had wind gust data. I could grab that, and just kind of like put it all on a slide and just annotate it with colors and text and call it a day. So sort of the result of that, so to speak, there's Governor Hochul. And so these maps of New York, if you can't see it, these are just maps of snowfall hour by hour, that kind of thing here. So someone at her team for that Bills game that got rescheduled, they took those maps, took out 2 of them for the game that was originally going to be played at like 12:30 p.m., put the Buffalo Bills logo on there where forecast was for a lot of snow, and then posted a different one that was for the time it was pushed to, where now the forecast is for no snow. So that was like their kind of cute way of saying, hey, the forecast is really bad here, but it's going to be better for when we're going to move the game. So that's kind of a fun thing. And then on the left there is the Erie County, which is the county that Buffalo is in, talking about it and tweeting out our product. And I thought it was kind of interesting. You sort of like Sharpied different parts or something like that. Highlighted, I should say. All right, so kind of wrapping up here, but those were a little more like cutesy ways that, that the data products were used, valuable in their own right, obviously, but not necessarily in quite as official as the context. But here's a couple other examples here. I mentioned that you need weather data for if you're going to do like a disaster request, something like that. So one in the middle here was talking about really heavy rainfall on Long Island, and they cited us here as talking about how much rain happened and what the recurrence interval for that was. The one on the left is Governor Hochul's team using one of our tweets that talked about tornado count. So we had more tornadoes this year in New York than have ever been reported before. Mostly just sort of a statistical curiosity, but obviously the places that got impacted had, real world consequences from that, and that's interesting in a political sense as well. So making use of that. Chuck Schumer here, Senate Majority Leader for right now, came and visited Albany, Syracuse, and Buffalo, and made a pitch for getting more funding for more federal funding, not for us per se, but the New York State Mesonet and just general weather infrastructure. So their team asked us to create some graphics here that summarize how many tornadoes or tornado warnings there had been over the previous couple of weeks and months. And so he's holding up some graphics that we made. This one's from Syracuse, this one's from Buffalo. So it's kind of fun. And then finally, I think this is the last thing I've got here. I've had all these examples of it in action, and then here's some from just literally like yesterday. So the one on the right, we made these nice timelines for spot forecasts for the Buffalo Bills. So here's Erie County, New York, where the Buffalo Bills play. Just saying, share this with your Buffalo Bills fans in your life, and then that's our spot forecast. The one on the left is a slightly different thing. It wasn't a spot forecast, but just kind of summarizing where we were weather-wise. And that's, again, the Erie County executive sharing a different briefing there. And then, the scary thing is that once something is online, you do not know what happens to it afterward. And so we had been posting these Bills spot forecasts because we knew that had we don't normally post our briefings online, but there was such like a general public component to that and interest. So we had been posting those. And I was just perusing CNN, and they had a story about they had a story about the Bills game, and the title said 20 to 30 inches of snow. And that was very noteworthy to me because I remembered that our most likely scenario here, I'm sure you can't read this, but it says 20 to 30 inches. And I'm like, they must have seen this. So I clicked on the article and it had like a link to this. And then I was like, oh, I wonder if other places have as well. So if you just go to Google and you search for State Weather Risk Communication Center and just make it the last 7 days, you'll see, you know, dozens, hundreds, I don't know, of stories pop up from everywhere from CNN to, you know, Daily Mail to your Times Union locally, but SF Gate, where because the Buffalo Bills played the 49ers yesterday, San Francisco, a whole range of things. And, you know, none of those organizations ever reached out to us to say like, hey, are you guys legit? Are you, is this accurate? So, I mean, I'm glad people are using it, but it's sort of a scare, you know, when something's out there, you don't know what is going to happen to it. But that's good. If it was valuable to people, then that's great. And finally, just ending here, you know, I said after Hurricane Ida, Governor Hochul said, what did we know? When did we know what we had? What information did we have? And we had not made these graphics yet for Ida that talked about the rainfall. They were not live. They were sort of after the fact, trying to figure out what we knew. But then, because we knew the sewer capacity and we have the mesonet data, we could turn that into a real-time product. And so we did after that. And then for that September 29th rainfall event that I was saying did a lot of flooding in Brooklyn and other places last year, that happened mostly in the morning, mostly from like, say, 8 a.m. to noon, give or take. And this is Governor Hochul at 9:25 a.m. saying Brooklyn is seeing some of the heaviest impacts of this rainstorm. And then she used the products that we had made there in real time. So it's a nice little kind of full circle. Like she put out this challenge of, hey, do something about this. And at least in our own tiny way here, made a product that was clearly beneficial to someone. So with that, I will stop and take any questions. Yeah.
Mesonet gives you the information now,
Yep.
but you do the future prediction. You have to realize the numeric weather predictions output, right?
Mm-hmm.
So you put in your own interpretation.
Yeah. So what we normally do is we'll take, so I'll try to say this in a general way because I know you would understand my specific example, but the National Weather Service runs numerical weather prediction models, like really high resolution checkerboard, chessboard kind of models that go out hours or days. And we'll take those model outputs and sort of slice and dice them to be just the part that we care about. So if we care about Albany County, we'll take just the checkerboard squares that are in Albany County, for example, and use those as our starting point. But all of those models helpfully bring in the New York State Mesonet data when they start off. So they have to have a starting point to go forward. You need to start somewhere. And so they use that data as their starting point, in part at least.
So you don't do your own AI
No.
type.
No.
You just repackage it.
Yes.
whenever you-
Yeah. We are
Then
just
there are two
right.
issues here. One is the uncertainty or accuracy.
Mhm.
Second, eventually going to run into that would be liability, especially from impact point.
Yeah. I don't want to think about the liability perspective, but I suppose I will have to think about that at some point.
Yeah.
But the uncertainty part is a good one because what often happens is if you're the National Weather Service, you have products you can issue. You can issue a winter storm watch or something like that. Those are frequently issued within about 36 hours of the event. And they do that because that's when you have more certainty. Like, okay, we're a day or two away. I know it's going to happen tomorrow. But the problem with that is that if you're the DOT and you just responded to a lake effect snowstorm, and now there's going to be a snowstorm on Long Island in 4 days, you want to move all your snow, your snow plows and trucks to Long Island, but you can't just do that with 24 hours notice because it's logistically very difficult and there's a choke point in New York City. So they would like to know information at 4 or 5 or longer days, But the problem with 4 or 5 days is that you don't have the certainty to say, oh yes, it's definitely going to be Long Island,
Yeah.
like it's hit by a snowstorm. So I didn't really touch on it too much here, but when we're at that lead time, most of our briefings have a most likely and sort of a worst case and a best case, so they can hopefully plan on, you know, I'm going to hope for the best case, but I'm going to plan on the worst case and know that the likely case is probably what's going to happen.
Okay, thank you.
Yeah. Yeah.
First, thank you. We had the governor previous to Hochul, who after Hurricane Katrina got up and said, when does the next 100-year storm happen? Hopefully, the governor is willing, this current governor is willing to put the money in finding out those things. That's at a more macro level. Got a question about the National Hurricane Center.
Yeah.
We see when they start publishing this storm is generating and getting a little bit more mature, we start seeing two types of models, at least that I as a consumer see. I see a European model and an American model. Is there a difference in the data they're collecting, or is this the lens and the way they're trained that they're looking at?
That's a really good question, and it's hard to answer that succinctly, but for the most part, it's about the model itself and not the information that they are collecting. And so Scott, when he gave me an introduction, he said that before I came here, I was working on Hurricane Sandy's track, and that was the archetypal, oh, the European model got it right and the American model did not. Turns out that if you take the starting data the American model used, and you use an American model, and you just use tweaks that make it more like the European model, suddenly you get the right track. So that is maybe an extreme scenario, but mostly it's about sort of, in some parts, the luck of the draw, what little constants you have in your model and how you deal with the data that's coming in. But the European models are generally thought to be superior to the American ones. Yeah. Yeah.
I know that you're talking about weather and not climate. But we have a new administration coming in next month. I'll just refer to it as the orange dip. But it says that it's all a hoax, that climate change is all a hoax. What do you expect in terms of weather under what we're coming into?
Yeah, so the question is basically what are my expectations of what's going to happen to the sort of federal weather enterprise as I understand it. You know, if you look at the Project 2025 kind of stuff, that's pretty scary, right? He talks about really downsizing NOAA and the National Weather Service, and especially their climate part, and saying that private industry can fill in the gaps. What I think probably most people don't know is that private industry, and I know we're not private, but we kind of function in that way, in this capacity, take 80% of their inputs from what the National Weather Service puts out, right? Like, they're not making their own tornado warnings. They're not running their own models in the most part. So it's not that simple, even if we wanted it to be. And I don't know of a single meteorologist who wants any downsizing to happen to the National Weather Service. I'm a little fearful, to be honest, but I guess hopeful that weather is not a blue or red thing, right? Like it impacts rural communities in the same way that it impacts cities. And so I know that both political parties historically have been very supportive of the federal weather enterprise, and I would like to think that that will continue, even if some individuals disagree with that. Yeah, I do. I have a 4-year-old, and I'm, yeah.
Well, first of all, in response to her question, we can just use Trump Sharpie to change the weather data anyhow. My serious question has to do with, especially around here, we seem to get a lot of weather events that are strongly differentiated by I'm saying altitude. Elevation. To what extent and in what ways are you able to incorporate that in the data you put together?
Yeah, so Honestly, this maybe not the best answer, but the products that we use that the National Weather Service already puts out, like the numerical weather models that they run, that we, like I said, we kind of slice and dice them. They incorporate elevation. So they generally do a very good job of giving you a signal of, is this going to be one of those storms where, it's going to be rain in Albany and snow up in the Catskills, or is it going to be one of those storms where it's snow everywhere, rain everywhere? So that's a really good starting point. And then, of course, the Mesonet has stations at different elevations too. And so you can kind of get a sense of, is it warmer here, colder there, so on. Yeah.
Looking at the Mesonet, it's an enormously rich data set. How are you archiving it? How will that be available for users? Because most of us don't want, soil temperature at every 10-minute interval.
Yeah.
For 20 years.
So they have a data request page. It's just, if you Google NYS Mesonet, you'll find the website, and they have a data request page, and they allow you to request data you can request just like a single variable for a single site on a single day, if that's what you wanted. Or you could request the entire data set. But all of the data is archived, like literally every number, every picture is archived. And so for the most part, it actually isn't that big of an archive, in the sense that most of the numbers, most of the data is just, 32.8 degrees Fahrenheit, like that kind of thing. Lots of numbers, but on the grand scheme of things is not necessarily like a huge chunk of data. Interestingly enough, most of the data is taken up in the form of saved pictures, just because a picture, picture is a couple megabytes, whereas a string of numbers is a kilobyte or something like that. Yeah. Yes.
Could you clarify what information that you just went over with us in the latter part of the presentation is available to the public?
So right now, the answer is right now, basically none of it. And it may not say like that, but that is mostly just because we're still figuring out like how we exist within the ecosystem of state government and how the state government interacts with the Weather Service, and we do as well. So because we were funded to help the state's government emergency management sector, not necessarily the general public, we don't put things online, and we don't really have a website yet, for example, because we don't have the computer guys or ladies hired yet. So the only reason we were putting out the bill stuff is because we were making it for the state's emergency management sector, but we also knew that had like a fairly obvious general public value. So we put that out. Now this might, if I did this presentation in a year, I might have a different answer for you, because hopefully by that point we'll have a website and we'll start archiving these things like on a website in some capacity.
Clarify if she's asking for data or the products.
Asking for the products, the
Yeah.
briefs, basically.
Yeah. Yeah, the same, yeah.
Same.
That's what I was
Yeah,
referring
that's
to.
what
Yeah.
that's what I thought.
Yeah. Oh.
Regarding your briefs, you said you could do region-specific briefs if requested, but in general, your daily brief is like a statewide summary.
Yeah, it's a statewide summary, but of course, if we know that a storm tomorrow is only going to affect Buffalo, we will specify like in Buffalo this will happen, and then outside of Buffalo a different thing will happen. And yeah, we are archiving all of our briefings, much like the Mesonet archives their data. And so I would like to think that in a year or two, we'll get to a point where we can put all of those online and have those in a place where people can go look them up. I think probably the concern right now is that maybe there's, since they're still such an evolving product, and honestly, we are still kind of new to this too. We've only been making briefings for about a year, that I don't know, getting back to the question about liability, is there a liability question? If, we put something in there, even as a low chance event, and it happens, and somehow the state looks like they didn't respond to something that it says we put in there, is someone liable for that? I don't know, but I suspect that is one consideration we'll have to talk with the state about, just how all of that works. Yeah.
When I listen to like a WAMC weather report, Jared Argianis, who happens to be a UAlbany ATM grad, he runs down the weather by, I guess it's maybe geographic regions. He'll say like the Champlain Valley and the Mohawk Valley, and is that mirrored in what you do with Mesonet? You have the same designations for the same areas?
No, it's a little bit different, but it's the same fundamental idea. So the Mesonet, when they divide up their stations, they divide them up by climate region. And the climate regions are not defined by us, but defined by NOAA or if someone else. When I was saying the DOT or like the Regional Economic Development Council regions, those are different regions from the climate regions and also different regions amongst themselves. And so when all of our states, agencies, and authorities were dividing themselves within their organization, they apparently didn't really talk to their neighboring organization because, you know, the REDC regions are 10, I believe, and those are a different 10 than the DOT, and those are different than the DEC and different than the Thruway and so on. So they kind of change depending on the user.
Probably with soil climate or soil types too.
Yeah.
Okay.
Yeah. Nature doesn't respect those boundaries, unfortunately. All right.
Tremendous.
Thank you. Okay.
Job, Nick. Janie says,
Thank you.
I gotta run. I got
Okay.
3
No
o'clock.
worries. Thanks, Jen, for coming.
Let me just mention our plans that are coming up. The Spring Speakers begins on January the 27th with a visit of Dr. Victoria Rizzo, who's the Senior Vice Dean for the ULB Center for Aging. And she'll give us a view of the initiatives within the College of Integrated Health Sciences and the Center for Healthy Aging. And our own Carol Whitaker will talk about the Emeritus Center's Lifelong Learning Institute and the spring schedule of courses and activities. And we'll get a chance, I'm sure, to hear about the synergies between the Alley and the college. For February, to celebrate the life of New York State's own Harriet Tubman, Dr. Janelle Hobson will speak to us about the grand engineer of the Underground Railroad. And Dr. Hobson has recently received much media coverage of her work on the history of hip hop and has even been able to connect Harriet Tubman's work with the STEM movement. That's at a date that we're still negotiating. She teaches. So it's a bit, interestingly enough, General Tubman was given that elevation this past Veterans Day, posthumously. Other speakers that have been confirmed, but no dates yet, is Dr. James Lloyd, Senior Research Scientist and Professor in the College of Nanotechnology, Science and Engineering. And he was speaking about the 1911 Vin Fizz, what was a drink, flyer, and its attempt to be the first across North America flight.
Yeah.
Between
Pasadena. Yeah, thanks for coming. Sorry.
And his adventures as the pilot of the Vin Fizz flyer in the reenactment of that flight. Cecilia Levy, who with her colleague Matthew Sadegas has received widespread notice on their work in dark matter. They'll be speaking to us. And we're awaiting supervisory approval from the New York State Library for Elizabeth Jacobowski to come and talk to us about culinary and foodway history in New York State culture. And further down the line, we'll be wrapping up with discussion on AI. And we're also contacting William Reese Fellow, mathematician Lindsay Childs, to see if he can come up and speak to us.
Yeah.
More information to follow.
Yeah. I'll try to get back to you on that. We have done, I have paper published. Oh, yeah, the bottom with the short-term precipitation.
I remember talking to you about it, with you about that in the treatment.
Yeah. So I'd like to push to use this data to retrain it.
Please do. Please share.
Yes. So I'll talk to you.
Okay. All right. Thank you.